So today we're going to be talking about queues. So this is sort of in addition to the stacks that we saw in the last video. Queues are similar to stacks, but a little bit different. So while stacks are last in, first out, we call that LIFO. Queues are first in, first out, or FIFO. Right? So the data type, so queues are a data structure that store a collection of elements, just like we saw with queues, except now we don't have push and pop. We have methods that we call enqueue. So enqueue puts an element at the back of the queue. So here's the back of our queue. Dequeue returns and removes the front element of the queue. So you're adding into the back and you're taking out from the front. So it's just like a line that you would have at a restaurant where you're waiting to give the cashier your order. So the person at the front of the queue is versus the person at the end. So again, just like we had with stacks, we have these three sort of methods that we sometimes implement, but not always. So one is it empty? So is the queue empty? What's the length? And can we just look at the front item without doing anything? So just like we saw before, enqueue of -3 is going to take this -3 and it's going to put it at the end of the queue. And really this should move back now to there, right? It just tells us where the back of the queue is. Similarly, dequeue is going to take this 3 here and pull it out of the stack. And once again, I didn't draw it in, but front would move over to the 10 here. So just like we did with stacks, we're going to go through a little example. Here we're not going to do merge sort. We're going to use, we're going to design selection sort to use a queue. So given an array, we want to sort that array, right? So again, we start with our unsorted array here, and our little algorithm says create an empty queue to hold the sorted elements. And then once we do that, we're going to search to find the minimum element, insert that element into the queue, and then replace its value in the array with infinity. And then while the size of the queue is smaller than the length of the array, repeat 2 and 3. Right? So we would implement this step using the queue.getLength. And then once we've finished that and everything from our array is now in our queue, we're going to dequeue the elements in order because now they're going to be sorted. We're going to dequeue them back into the array, replacing those infinities that we had added before. Right? So the first thing is create a new queue. We've created our new queue, and the front and back pointers sort of point somewhere because this queue is now empty, right? And the first thing it says is search through the array to find the minimum element. Well, the minimum element is this -22 here. So we take that 22 and we change it to infinity. Change it to infinity and add it to our queue. Right? Looks a bit nicer when we do that. And then now we get here in our queue. So while the size of the queue, so the size of the queue here is 3, is smaller than the length of the array, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, so 3 is less than 10. So we're going to go back to step 2. And step 2 says search for the minimum element. Well, now that this is infinity, right? Negative 22 is no longer the minimum element, so negative 12 is. So once again, we replace negative 12 with infinity and add negative 12 to our array, or into our queue. We do the same thing with negative 4. Negative 4 is now our minimum element because we've replaced negative 22 and negative 12 with infinity, the biggest numbers possible. So negative 4 is now our minimum. We replace it with infinity and add it to the queue. Next we find 0, replace it with infinity, add it to the queue. We do that with 4. And then we get to this situation where we try and find the minimum. Well, what's the minimum here? Is it 5 or 5? Or does it matter? It doesn't really matter, right? Because these aren't independent values. They're just 5 and 5. Eventually, we're going to put both into the queue. But which one we add doesn't really change anything. So first, we're going to insert 5, and then we're going to insert 5. We do the same thing with 12, and then 17, 28. And now we get to this situation where the size of our queue is 10, and the length of our array is 10. So 10 is not less than 10, right? So now we pop out and we go to 5. So 5 says dequeue the elements back into the array in order. So we're going to dequeue, we're going to run dequeue, and that's going to eliminate 22, and we're going to place it right here, right? Boop. And now 22 is in its correct place. And we're going to keep going down the line, dequeue negative 12, insert it into the next element in the array, dequeue negative 4, dequeue 0, 4, 5, 5, 12, 17, and 28, right? And now our queue is empty, but our array has all of those elements in sorted order, right? So normally in selection sort, we, either from the front or from the back, we pick the minimum and maximum and we swap some things. Here, instead of swapping things, we're going to move them into the queue and then eventually move them back into the array. Right? So that's one way to use a queue for sorting. So we saw in the last video how to use stacks for sorting, and in class we saw stacks for sorting. Here we're using queues for sorting. Is it more efficient than using an array by itself? Not necessarily. Does it serve a purpose in knowing how to use queues and as an example? Yeah, for sure. Would we ever use this in practice? Maybe. Maybe. You never know, right? Okay, so in the next video, we're going to talk about actually implementing queues using arrays as the underlying structure, and we'll talk about those a little bit in class as well.